Hello everyone, I Dr. Nikita welcome you in my pharma lecture series. Kindly like, share, subscribe my channel and post your comment for any of your required topics. We are going to see coagulation or precipitation. We have seen how the potential is developed around the particle in my other video, then how the potential is responsible for the stability of the particle. Coagulation or precipitation and aggregation. As you know, the ideal system consists of the particle having sufficient zeta potential and the stability. They have repulsion with each other, they repel each other, and they do not come close and they do not have traction interaction overcoming the repulsion. Because of which the system is stable, homogeneous, there is no flocculation or aggregation of the particle. But when the potential is disturbed, the particle combine together and they aggregate. It leads to the instability. So how it is happening that we will see. You have these particles and these are, okay, they are not coming close and they are not getting attracted toward each other and they are stable. But when you add the electrolyte, they are getting these counter ions and they are getting neutralized and they are forming the microfloccules. So these are like your microfloccules, small particles joining together. These are called as the microfloccules. Okay. Now, once the microfloccules are formed, these microfloccules combine together and they form the macrofloccules. They are forming because of the van der Waals interaction between them. So they have the attraction forces, the van der Waals interaction, which causes microfloccules combine together to form the macrofloccules and they become the aggregate and sizes increase and greater in number. They start settling down, which is called as the sedimentation of the system. So you may see something like that into your system, that this is your liquid, and because of the sedimentation you will see all the particles are settling down, or your system is having two phases. Clearly you can see the solution separate and the suspend particles separate. So that is called as the two phases separation, called as the phase separation or the caking. So this system is called as the deflocculated system. And this system is called as the flocculated system. So if your electrolyte is having higher valency, it has a higher tendency for the flocculation. The degree of flocculation is more for the electrolyte having the higher valencies. Okay, so you understood what is the deflocculated and the flocculated system. Now you have protective action of the colloid. Okay, now you can see this lyophilic soul surrounded by the lyophobic soul to prevent the aggregation of the protective action. And example is gelatin is used to prevent gold colloid by addition of the sodium chloride. So you know that lyophilic soul, they have the good interaction with the dispersion media. They absorb water. Okay, they have good absorption tendency and they form the layer of water around them. When you add gelatin solution which is swollen, it forms, this is suppose gold particle, and if you add the sodium chloride, that is like an electrolyte. This is the gold particle and this is the electrolyte from the sodium chloride, counterbalance each other and hence they lead to the flocculated system. But when you add gelatin, this gelatin molecule forms a layer around this gold particle. So they prevent the interaction of this electrolyte molecule with the gold particle and gives the protective action. Okay, so we have seen that is the lyophilic soul when they do not carry charges, and even because of that they are stable at high concentration of electrolyte addition. But lyophobic soul, they carries the charge on it, and even the small proportion of electrolyte when added, they lead to the instability of the system. So you have seen how the deflocculated system is there and flocculated system there. So you have the gold number. So gold number is the number of milligrams of the hydrophilic sol which is required to prevent precipitation of 10 ml of gold sol by addition of the sodium chloride 10%. So it is basically the number of particles of the hydrophilic sol required to prevent the precipitation of your metal sol particle by addition of the electrolyte. Please like, share, subscribe my channel and keep watching my videos till end for better understanding. Have a great day. Thank you very much.